I build, I code, I innovate. I didn't know the serial Oscar welcomes you to Enlightenment Hub. In this video, I am going to explain what an Astable Multivibrator is, how it works theoretically, its application, and we are going to practicalize it by building one. An Astable Multivibrator is a circuit that switches itself on and off repeatedly without needing external trigger. The word astable means it has no stable state. It never stays on or off permanently. While it is called a multivibrator because it continues to switch between two states, producing a kind of electronic vibration. They are essential in electronics for generating continuous on and off signals. They are present in projects like blinkers, alarms and digital timers, and so on. The working principle goes like this. Basically, one transistor switches on while the other switches off, and then they swap roles, creating a repeating cycle. Let's take a look at the circuit diagram and let's understand it better. Come closer. So this is basically the circuit diagram of a Astable Multivibrator. So here we have a 9 volt supply, resistor R1, R2, R3, R4. We have 2 LEDs to indicate the on and off states. We have 2 electrolytic capacitors. We have two bipolar junction transistors. When this switch is closed, current flows into resistor R1, R2, R3. According to Kirchhoff's current law, here becomes about 3 volts according to the value of this resistor. Here we're having 0.7 volts with respect to the value of this resistor. After the switch is closed and the current flows into the circuit, the 2 capacitors charge exponentially while they both have 0.7 volts at their negative ends. Due to circuit imbalance, one transistor turns on before the other. Let's assume the transistor T1 turns on first. So current flows through the transistor T1. That means the electric current is able to make its way to the ground from these 3 volts entering the ground. In the process of that, the capacitor C1 starts discharging. Electric current starts going to the ground as well. So in that process, this LED is illuminated. Now as the capacitor C1 starts to discharge, the stored charge, which is about 9 volts, now we are giving reference to the negative terminal of this capacitor. The 9 volts becomes a negative voltage on the negative terminal. Summing it to the positive 0.7 volts plus 0.7 volts, then we end up with 8.7 volts. So present here we are going to be having negative 8.7 volts. So this negative 8.7 volts prevents this transistor T2 from turning on. The capacitor C1 discharges. During the process of all this, the LED 1 is turned on. Gradually, the voltage across capacitor C1 increases from negative 8.7 volts to match the supply voltage. Once it gets to 0.7 volts, the voltage is now sufficient enough to turn on transistor T2. So let's see what happens. In that process, capacitor C2 is still fully charged with the supply voltage. As the voltage across the capacitor increases from negative 8.7 to negative 6.5, then to negative 3 to 0.1 volts, till it reaches 0.7 volts, positive 0.7 volts. During that time, the stored electric charge inside the capacitor must have dissipated. Then this 0.7 volts now is capable of turning on this transistor T2. So transistor T2 gets triggered. Once transistor T2 is turned on, so the current flows coming down, powering this LED, second LED, causing it to illuminate and finding its way to ground. In the process of that, the capacitor C2 starts discharging. And simultaneously, this voltage analysis happened here as well. So we are having about negative 8.7 volts right over here, which is being supplied to the base of transistor T1, negative 8.7 volts. It turns off transistor T1, doesn't allow current to flow any longer. In the process of that, capacitor C2 starts to discharge while capacitor C1 charges. As the voltage across the capacitor C2 increases to match the source voltage, just as I've explained, the gradual process, negative 8.7, negative 6.5, negative 1 volt, negative 6.5 volt, for instance, negative 0.1 volt, then we have 0.1, then once the voltage reaches 0.7 volt, that will be having 0.7 volt here. It triggers the base of transistor T1, causing it to turn on. The negative terminal of the capacitor C1 again becomes negative 8.3 volts, which turns on the transistor T2, causing capacitor C1 to discharge. while capacitor C2 starts charging again, and the cycle continues. Like that, we'll continue to have a square wave output. Now that the working principle is understood, we will now be looking at how we can build one ourselves.
The starting point for the PCB making process begins with the KiCad software. Without wasting much of our time, the circuit diagram has been drawn already. Here we have the connector that connects the board to the power, the resistor R1, R2, R3 and R4, the two light emitting diode, LED1 and LED2, the two polarized capacitor, capacitor C1 and capacitor C2, and the bipolar junction transistor Q1, Q2. Once the schematic diagram is completed, we can now click on the export button to export the circuit into a PCB layer format. The circuit has been arranged the way I wanted it. While you are designing your circuit, feel free to play around with it and come up with different manufacturing designs. The circuit still retains our 2 LED, our 4 resistors, 2 electrolytic capacitors, the 2 bipolar junction transistors, and the point of connection. After completing the circuit design process from the schematic diagram to the PCB layout, then you can now proceed to printing the circuit to start the etching process. There are different options to which you can print from. We have the FCU, the front cover face, where the copper is being laminated to. The F mask for the printed masking process. User drawing, user comments, margin, and so on. By clicking the preview button, you get to see what they look like on the white sheet before printing them out physically. After printing out the circuit and have completed the etching process, you should have something similar to this. For those of you that doesn't know what an etching process is, endeavor to watch my videos on Introduction to Printed Circuit Boards and Etching Process. After completing the etching process, it is essential for you to conduct a continuity test to ensure that all points are connected together properly. This is a UV curing soldering mask ink. It is used for coating the face of the board. Using steel wool, scrub off the impurities on the surface of the board to ensure that the board is neat before applying the ultraviolet soldering mask ink. Now apply the soldering mask ink and spread it evenly across the board. Using this blue transparent plastic gotten from the normal A4 paper spiral binding, place it on top of the applied ink. Use your fingers to apply pressure to ensure that there are no air bubbles present. With the aid of a biro ink and a long sharp stick, apply the ink to the points you wish to protect from the exposure of the ultraviolet rays. This is an ultraviolet light. It serves as hardener to the soldering mask ink. Focus it on the UV ink and watch it solidify. After the ink solidifies completely, remove the plastic. Using a cotton wool soaked in alcohol, clean the PCB thoroughly and your soldering points appears. For the top face marking, using the toner transfer method, join the paper to the surface of the board. Apply it with the aid of a pressing iron. After sufficient heat is applied, soak the PCB into water, then gently rub off the paper from the surface of the PCB. Now that the PCB is ready, let's start soldering. Using the above stated electronic components, place each component where they belong. With the aid of a soldering iron and a soldering lead, commence the soldering. After the soldering job is done completely, the circuit can now be powered and give the expected output result. So here we have it, our completed Astable Multivibrator.
Now, we now have a full working Astable Multivibrator. Well, I hope you've grasped the full concept of an Astable Multivibrator. From what an Astable Multivibrator is, how it works, its application, and how to make one. Thanks for your full attention, and I hope to see you next time. Kindly subscribe to this channel and hit the notification button for more amazing and educative videos like this. This is Adenu, the Serial Star. See you our next time.